let us take a better example than this, which is practically suitable to you. You are given, let me say, you have to give 3 examinations. One is JEE examination. Another one is, let me say, WIT examination. Another one is something like some SRM university examination. You are giving all these 3 examinations. After writing the examination, let us suppose all these are online examinations. You know the marks. That after you finish the examination, let us suppose you know the marks and you know the cutoff marks also. So that in such a case, you must know the possibility of selection of yours for JEE or WIT or SRM, whatever it is. So in such a case, you want the selection in JEE. You want the selection in JEE. That means probability of selection, let me say, as A. Selection, let me say, as A. So probability of your selection for JEE, P of J, given A must be sum of all these probabilities. That is probability of A after J plus probability of V after A after V plus probability of A after S. You need this one. So which is to be taken up. That is probability of A after J, like this. Okay. Now, if you see the Bayes theorem, generally the confusion is the Bayes theorem, where it is to be applied. The Bayes theorem is to be applied whenever an incident like A happens with the different events, and we need the probability of that event to occur with a particular event. In such a case, you have to apply the Bayes theorem. Now, if you go through the definition which is on the slide, you can see that, please. That is Bayes theorem. If an event A can occur only with one of the n mutually exclusive and exhaustive events, What does it mean by mutually exclusive and exhaustive events? Nothing is common to them. Their intersection is always phi. That means that all the events B1, B2, B3, so on, Bn are mutually exclusive and exhaustive events, and the probabilities of P of A after B1, please go to the slide. Probabilities of P of A after B1, P of A after B2, and so on, P of A after I are known to us. You must know all of them. If you add all of them, you will be getting the sum of the probabilities. And what we need is the probability of occurrence of event A with an event I. Bi is defined to be P of Bi into P of A after Bi, whole divided by, this is sigma P of Bi into some P of A after Bi. You can take it as R also, not a problem, because we have taken a particular event as I. This R runs from some 1 to n. N mutually exclusive events are there. So how do you understand it? Simple. Keep the formula aside. How do you understand it? The classical definition of probability is number of favorable outcomes divided by total number of outcomes. In this case, now it is simple, very simple. Favorable probability upon total probability. What is the difference now? In case of classical definition on probability, number of favorable outcomes for an event to occur, whole divided by total number of outcomes in the classical definition. It is modified like this. Whenever a particular event is occurring with different events, and we need the occurrence of this event A with a particular event Bi, then in such a case we apply the Bayes theorem. So simple, understand like this. Bayes theorem is defined to be favorable probability divided by total probability. Whenever the case of total probability comes and you need the occurrence of that event here with a particular event, then you have to make use of this. This is nothing but the total probability. From this total probability, we take the favorable probability which is required to us, that will give you the probability of occurrence of BI after the occurrence of A is nothing but favorable probability divided by total probability. This is simply the Bayes theorem. So understand Bayes theorem like this. Particular event occurs with many events. Then if you add the probabilities of all of them, then you will get total probability. And if you want that particular event to happen with a particular event, then you have to take that to the numerator, which is nothing but the favorable probability. So if we take a problem on this one, you will better understand this. Now let us take this, and proof of the Bayes theorem is also important for you in the boards level. So you learn the proof also for Bayes theorem. It is also very simple, very simple. Now let us see a problem now. A purse contains two six-sided dice. A purse contains two six-sided dice. Generally the die is consisting of 6 faces only, and one is a normal fair die. Normal fair die means it has 6 faces, and 1, 2, 3, 4, 5, 6 are marked on it. They are equally likely and exact to events. Getting 1 or 2 or 3 or 4 or 5 or 6 are equally likely and exact to events. That is nothing but a fair die. Fair die. While the other has 2 1s, 2 3s, and 2 5s. Other die consisting of 2 1s and 2 3s and 2 5s. Please go through the sentence, that sentence. While the other has 2 1s, 2 3s and 2 5s. Then how do you understand this? What is the probability of getting 1 on a fair die? On a fair die is 1 by 6. What is the probability of getting 1 on a fair die is 1 by 6. What is the probability of getting 1 on the second die in this case? That is a biased die. Biased die. How many 1s are there? 2 1s are there. How many total number of outcomes are there? 6 are there. So it is 2 by 6. Do you find the difference? On a fair die, getting 1 is 1 by 6. On the biased die, getting 1 is 2 by 6. Understand that. A die is picked up and rolled. A die is taken and rolled. Then because of some secret magnetic attraction of the unfair die, because of some secret magnetic attraction of unfair die, there is 75% chance of picking the unfair die. Understand that. The secret of attraction makes it possible to attract or to pick up the second die only more. What is the second die? Second die is an unbiased die. It has 75% chances to pick up. Generally, how do you see this problem? When you have 2 fair dice, picking up 1 die or picking up 2 second die, what happens? The equal chances will be there. That is 1 by 2 is the chance to pick up the first die. 1 by 2 is the second chance to pick up the second die. But in this case, these are biased due to magnetic attraction. The second die can be picked up in 75% ways. That is 75 by 100 means 3 by 4. So picking up the fair die is only 1 by 4. That is the data given. And the die is rolled and shows up the phase 3. Die is rolled and shows up the phase 3. Die is rolled, die picked up and thrown, and it is showing the phase 3. Okay. The probability that a fair die was picked up. The probability that a fair die was picked up. Let us apply now the Bayes theorem. See. Now let me say here, in this case, A, getting 3. Getting 3. B1 is fair die and B2 unfair die. Okay. What is the probability of B1 fair die? No? So getting 3 is 1 by 6. What is the probability of getting 3 on the unfair die? It is nothing but P of B2 is nothing but 2 by 6. Understand? Why 2 by 6? 2 3s are there. You can see the problem there in the second sentence. The second die has 2 3s. That is why it is 2 by 6. 2 by 6. Now, what is the probability of picking up? What is the probability of picking up the first die? It is P of B1. What is the probability of picking up the second die? Second die is 3 by 4. 3 by 4. Understand that first. Now, let us write what is required there in the problem. The die is rolled and shown up the face 3. It is given that it has shown up 3. So, we have written the probability of showing up 3. Now, the probability that a fair die was picked up. Probability that a fair die was picked up. Simple. Always remember, fair die is this one. So, it is to be written P of B1 after A. P of B1 after A is written here. So, what do we require? Probability of A intersection B1 union A intersection B2. What does it mean? Either getting 3 may happen with B1 or getting 3 may happen with B2. That's what I have written here. A, that is getting 3 may happen with B1 or OR. This is union. Or it may happen with B2. But what do we need? We need it to happen with B1. Okay. Now, in this case, probability of B1, let me write this in this way, A after B1. A after B1. And this one is A after B2. Okay. Now, what should it be? What is A? Picking up the fair die. B1 is picking up the fair die. Picking up the fair die is nothing but it is 75% chances are there. You can see that 75% chances to pick up B2. So that is why 75% means you can understand it is nothing but 3 by 4. 3 by 4 for B2. But for B1 what happens? It is only 1 by 4. 1 by 4. And what is getting number 3 on this one? 1 by 6. This union stands for plus. And what is the probability of picking up B2? B2 is here 3 by 4. And what is the probability of getting 3 on B2 is 2 by 6. So what we wrote here, we have written the total probability first, and from this one we are interested to get the number 3 from the fair die. Fair die. What is the probability of getting number 3 on the fair die? It is this one, which is nothing but the favorable probability. 1 by 4 into 1 by 6. 1 by 4 into 1 by 6. So what should be now? The 6 into 4 is LCM 1 upon, it is 1 plus 6. It is, if you simplify this, you'll get the answer. It is nothing but 1 by 7. I repeat the problem. This is A getting number 3. B1 is the fair die. B2 is the unfair die. So A happens with the 2 events here. What are they? B1 and B2. So what is the probability of B1 picking up B1? Let me write that also. Picking up B1, because you can understand that I didn't write that. P of B1. And what is the probability of picking up B2? Probability of picking up B2. B2 means it is given that it is 7 due to some magnetic attraction, it has 75% chances. So that is why it is 75 by 100 is nothing but 3 by 4. When it has 3 by 4 chances, it will have 1 by 4, obviously, because only two exhaustive events are there, B1 and B2. The sum should be 1. So if it is 3 by 4, that should be 1 by 4. Now let me apply. What is our requirement here? The occurrence of event A, that is getting number 3, must happen with fair die. That's what we want. But the occurrence of event A may happen with B1 or may happen with B2. That is why I wrote both. That or. This becomes plus. And what is P of B1? What is P of B1? It is 1 by 4. Conditional probability, please. Conditional probability, it is nothing but 1 by 4. What is the occurrence of getting number 3 with the B1 is 1 by 6. 1 by 4 into 1 by 6. And it is nothing but 3 by 4 into 2 by 6. What we need is, it must occur with A. That is why it is sent to the numerator. 1 by 4 into 1 by 6. Now if you simplify this, it is 1 by 7. This is nothing but the Bayes theorem. Very simple. It is important for all the boards. All the boards. If you check out your CBSE textbook of probability, then you will have a separate exercise on Bayes theorem, which is very simple. So simply see the Bayes theorem in this way: favorable probability divided by total probability. This is nothing but the Bayes theorem. So what I wrote from this one, this is total probability. What I require this one as favorable. That is why it is sent to the numerator. So this is what the application of Bayes